Hello friends, welcome to this session on the basics or the fundamental concepts of protection system. In this session, we are going to discuss about the importance of CT polarity in protection system. Most of you who are working in the industry or in the power sectors are already aware about this importance of CT polarity in case of power system protection. Many of the commissioning engineers or most of the protection engineers working inside the substations are already aware that almost always, when I say almost always, then there are some conditions that I will discuss separately. For the time being, let us consider that always the CT star points are formed towards the protected object side. And this is a general thumb rule. Everybody will always ask you to form the CT polarity or CT star points towards the protected object side. Most of the time, it happens that the person doing this connection inside the secondary terminals or inside the CT marshalling box in switchyard, they might not be aware about these things. They might not be knowing that why they are doing this CT star points in the protected object side, and they make these connections only because someone had told them to make the connection like that only. So now, in order to understand these things, in order to understand and in order to implement the correct CT polarity in case of your uh, protection system, it is better to understand these concepts beforehand. Now, this topic or the importance of CT polarity in protection system is applicable for all the sessions. That is, it is applicable for transmission line protection, it is applicable for transformer protection, it is applicable for bus bar protection, reactor protection, that means these shunt reactors, line reactors, bus reactors, all types of reactors, motors, generators, everywhere the importance of CT polarity is very, very high. Now, in this session, we are going to discuss about the importance of CT polarity and basically the importance of CT star point in case of transmission line protection. Remember that the understanding of this concept in this session is through a very simple uh, slides, through a very simple handmade slides basically. These slides are prepared by me, and it might happen that in some of the slides you might get the content which are not visible properly, as well as in some of the slides you might get the content that are not legible properly. But kindly bear with me. I will explain with uh, full dedication. I will explain with the complete clarity what are the practical importance of CT star point, practical implications of CT polarity in case of your substation, especially the transmission level, distribution level, and sub-transmission levels. Now, without wasting any further time, let us start with our topic of CT polarity and its importance in protection system. So, first of all, in this session, we are going to discuss about the CT star points and its importance for directional relays. In case of directional relay, the CT star points basically determine the direction of your relays. That means whether the fault is in the forward direction or the fault is in the reverse direction is determined from the CT star points or from the current direction in the secondary of the current transformer. And we will discuss how in the coming slides. So now the directional relays can be of two types, directional earth fault and directional overcurrent. But also remember, if you remember from the first session, then your distance protection, I have explained that there are four different zones: zone 1, zone 2, zone 3 and zone 4. Zone 1, zone 2, zone 3 are forward looking zones and zone 4 is the reverse looking zone. That means the importance of CT polarity and CT star points is very high in case of transmission line distance protection also. In order to understand the transformer protection like the differential protection and REF protection, you must understand the CT star points and CT polarity connection that we will discuss in the next session probably. In this session, we will keep ourselves only up to transmission line protection. Remember that the understanding of CT star points will help you to understand some of the most complicated concepts in case of 1.5 breaker schemes, where I am going to explain you in the coming sessions how the CT star points are parallel for the main and tie base CTs in case of transmission lines, and why when your transmission line is in shutdown conditions, and although the complete dia is in closed condition, that means all the three breakers of 1.5 circuit breaker schemes are in the closed condition, how then the CT currents are distributed, why we get zero current inside our distance protection relay, and what happens when your tie bay is in open condition, what happens when you're the other side of the dia. That means if there is one main bay, then tie bay, and then the second main bay, then what is the effect of opening of second main bay on the tie bay current, and then its effect on distance protection relay, that we will discuss in coming sessions. So in order to understand those complicated concepts, it is imperative to understand the concepts of CT star point, the concept of CT polarity in this session. For a simple double main schemes or double main and transfer schemes or any busbar schemes which employs only a single CT for line protection. Now we are considering the case of transmission line protection, in which we will discuss with you the formation of CT star point towards the protected object, and in our case what is the protected object? It is transmission line. So now consider this is a transmission line which is connected between two buses of two different substations. That means substation A and substation B. There is a transmission line in between them. We are having a distance relay at this substation A. Likewise, we will definitely have a distance relay at this end also, but our focus is over here only. We have a distance protection relay at this end. Suppose we are having two different cores of current transformer, core 1 and core 2. Core 1 of this current transformer, and for understanding purpose only, I am mentioning over here is CT1. CT1 is used for transmission line protection and CT2 is used for bus bar protection. You know from the basic concepts that always this CT1, which is used for transmission line, we have to form the star points on the P2 side in case of primary, and for the secondary it will be on the S2 side. While the CT2, which is used for the protection of bus bar, which is shown by these green lines, CT2 is used for the protection of bus bar, and your bus bar is on the P1 side of this CT. That means for this core 2 or CT2, you have to form the star points on the P1 side. That means in case of secondary, it will be on the S1 side. Now we will focus only on CT1, and these things are written over here, that this CT1, which is used for line protection, so its star points must be formed on the P2 side. CT2, which is used for bus bar protection, so the star point must be formed on P1 side. And now we will explain why the star point must be formed on P2 side only for transmission line. What happens if we form the star point on P1 side? How the relay behaves, that we will discuss in the upcoming slides. Before understanding these concepts, there is one very basic concept of CT polarity, and this concept says that this is the CT which I have drawn over here. P1, P2 designates your primary terminals, and S1, S2 designates the secondary terminals. Do remember that some utilities and in some textbooks, generally in place of P1, P2 and S1, S2, some dot markings or the square rectangular markings are shown, and in the case of dot matrix the designation is exactly the same. So first we will understand with P1, P2, S1, S2 nomenclature, then I will explain to you the concept of polarity marking using dot convention. So first P1, P2, S1, S2 nomenclature. What this CT polarity marking says is that if your current enters through P1 on the primary side, then in the secondary side the current will always leave through S1 terminal. Vice versa, you can say that if the current leaves through P1 in the primary side, that means if the current leaves through P1 in the primary side, then the current will enter from the S1 side in the secondary. In case your utility, or in case you are using in your scheme drawing the dot convention, that means the dot convention generally says is that whenever your current enters through the terminals or dotted terminals of the primary side, then the current in the secondary side will leave through that dotted terminals only. So now we will discuss the first concept of CT star points in case of transmission line. So this is the same diagram where I have considered a transmission line between two substations, substation A and B, and CT1, which is used for protection of the transmission line, and this is P1 P2 terminal. So we have to form the star point on the P2 side. So this is the basic diagram. Now you have three set of CTs, one for R phase, another for Y phase, and third one is for B phase. The P1 and P2 of the primary side is shown over here. That means the corresponding secondary terminal will be S1 S2 for R1 phase, S1 S2 of Y1 phase, and S1 S2 of B phase, R phase, Y phase, and B phase, which is the phase marking is not shown over here, but it is generally assumed that this is R phase, Y phase, and B phase. Now, since your transmission line, which we are protecting over here, is on the P2 side of this city, on the primary side, that means you have to form the star point on the S2 side. That's why if you see over here, the R phase S2 terminal is connected to Y phase S2 terminal, and then it is connected to B phase S2 terminal. That means your star is formed on the P2 side. Now look at here. This is your distance protection relay. This is the relay which is shown over here. So this 21 relay is now magnified, and this magnified image of this distance protection relay is shown over here. Remember that this designation is exactly the same across different manufacturers, across different vendors of the relay. That means be it 7SA522 of Siemens, REL670 of ABB, D60 of GE, P444 or P442 of Alstom, SEL421 of Switzer Electric Laboratories. In every relay, the internal algorithm for current direction determination is exactly the same. And what this current direction designation is, so now this is your P1 P2 terminals of R phase, Y phase, B phase, and you have formed the star point on the P2 side, or more specifically on the S2 side in case of secondary terminals. You have brought out the P1 terminals or the S1 terminals of R phase, and it is connected to the R phase CT, internal CT of the relay. Similarly, Y phase is connected to the Y phase, and B phase is connected to the B phase. Now this star point, inside the relay also you will have RYB and neutral CTs, or sometimes R phase, Y phase, B phase, and these three terminals are connected together, and this forms the neutral CT. So now this terminal, the star point, is connected to the neutral. The basic algorithm or every numerical relay is exactly the same. If your current inside the relay enters through the phase CT and leaves through the neutral, then it determines it as a forward fault. And if your current enters through the neutral CT and leaves through the phase CT, then it will detect it as a reverse fault. So now in case of your first case, these are the connections, and now consider a R to N fault or R phase to ground fault on this line in the forward direction. Now, if there is a fault at this location, this CT will see a current in this direction. So now if you see over here, in case of primary, the current is entering through P1 side. So in case of secondary, current will lead through S2 side. So this will be the current will lead through S2 side, or current will enter through S1 side. So now this is the current direction, S2 side current leaving, and now it is coming to the R phase CT of the relay. Now from this Q5 Q6, it may be any terminal. From this terminal, current now through this neutral, it will go back, and now it will go back to S1 and then S2, and it will keep circulating like this. So if you see over here, in the primary side of this CT, the current enters through P1, so that means your current will leave through S1 terminals of the CT, which is the main CT, or which is the CT over here, which is used for the protection of transmission line. Inside the relay, current enters through the phase CT and leaves through the neutral. That means the relay will determine it as a phase fault. So now see, this is a fault which is in the forward direction, and relay sees the fault is in the forward direction. That means if your star point is towards the protected object side, then the relay will see a forward fault as a forward fault and a reverse fault as a reverse fault, and it will operate depending upon the resetting of the relay and the actual impedance calculated by the relay. Now consider the case in which your star points is formed incorrectly on the P1 side. So now the everything is exactly the same. The only change over here is that now your star point is formed on the P1 side, and the P2 side is connected to the relay phase cities. So this is R phase P1 P2, Y phase P1 P2, B phase P1 P2, and P1 of all three phases are connected together to form the star, and this star is connected to the neutral of the relay. Now R phase is connected to the R phase terminal, Y phase is connected to the Y phase terminal, B phase is connected to the B phase terminal, and consider this as a R phase to ground forward direction fault. So if there is an R phase to ground fault over here, the current in the primary side will be in this direction, which is shown as IF over here. So current is entering through P1 terminal, so it must leave through S1 terminal, which is exactly the same case over here. So now current is leaving through S1 terminal. So now current is leaving. Current is in this direction, this. Now if you see over here, current enters through this terminal of the relay and it leaves through this terminal of the relay. That means if you compare from the last diagram, what happens is that now the current enters through the neutral terminal and leaves through the phase CTs. So current enters through neutral CT and leaves through phase CT inside your distance protection relay, and relay now detects this fault as a reverse fault, although the fault was in the forward direction in the actual field. So fault is in the forward direction, but due to the incorrect star points, which is not formed towards the protected object side, relay sees the fault in the reverse direction, and now the relay might not operate or relay might operate incorrectly. Similarly, it might happen that for a reverse fault, relay sees the fault in the forward direction and it will operate incorrectly. That means if there is a bus fault and your city polarity is in the reverse direction, it might happen that for a bus fault, your transmission line might trip. So in this session, and especially in the last two slides, we have understood why the city star points are always formed toward the protected object side by using our two different cases for the transmission line protection, one in which the star points are formed correctly towards the protected line side, and the second case in which the star point is formed incorrectly away from the protected transmission line. Hopefully, this concept is clear up to this point. In the next session, we will discuss about the importance and the relevance of CTA star point in case of differential protection. And when I say differential protection, then it will be applicable for all. That means bus bar, transformer, reactor, generators, motor, everywhere, wherever the differential protection is used. The concept and the applications of CT polarity will be exactly the same. Also, in the coming sessions, we will discuss about the connections of city in case of 1.5 circuit breaker. If you see over here, we are using the scenario in which only single line cities are used. So this might be the case of double main scheme or double main and transfer scheme or single bus bar scheme. But for 1.5 breaker scheme where you have two different cities, one of the main bay and another of the tie bays, then you must understand how these main bay and tie bay cities are connected in parallel. That we will discuss in separate session. Again, we will discuss what will be the effect of tie bay open, what is the effect of the other main bay in the same dia open on the current distribution, how relay remains stable in case of bus fault, how relay behaves in case of line fault, why we see zero current or zero load current when your transmission line is in shutdown but both cities are in charged condition. So everything we will discuss in subsequent lectures. Kindly remember that understanding of these concepts are very, very important for understanding of the concept of various protection systems like the differential protections which we are continuing in our transformer protection series. So we will keep up to this point only. Thank you. And if you like the content, don't forget to share these videos with your friends, with other protection engineers so that more and more people will be aware about these concepts. More and more people might be able to apply these concepts in their organization, in the field, and our motives of educating more and more people about the various concepts of transmission lines protection and power system protection will be spread towards various protection engineers of various age groups. So, thank you for watching. And also, if you don't like the content, then please comment in the comment section what other changes, what are the requirements, or what other modifications that you want, so that we can incorporate the same from our coming sessions onwards. Thank you again. We will meet in the next session with some other topics. Goodbye.